So we continue with heat transfer, and we are going to now see that how the uh, expansion, that is the thermal expansion which is taking place, is going to be applicable in a day-to-day basis. So daily life mein the use of the thermal expansion is not we are going to see now. So some applications of thermal expansion of solids in daily life. First one, construction of bridges. See, nowadays the bridges are made up of complete concrete, but originally olden bridges like the Howrah Bridge and all, they were made up of steel girdles. Now steel being a material which would get expand and contract in summer, so it used to happen that वो लैंड के ऊपर से जो ब्रिज रखा है, it was getting distorted. So what they did was that the bridge was made in such a way that if this is one end of the bridge and there is another end of the bridge, so the bridge was made over here like this. This was the bridge which was made, so we can consider the bridge to be made. ठीक है, ऐसे करके एक bridge there. So this is the bridge what they made. Now over here this was fixed. Okay, this part was fixed, but over here, instead of keeping it fixed to the ground, they had put rollers over here. Now what is the use of the rollers? So in case of the summer season when it expands, so this becomes a bit more in length, so थोड़ा आगे जाएगा. And वही चीज in the winter season, it will contract and it will go a bit inside. So in this way, the rollers will help the movement of the bridge. Okay. Now if this would have not been the case, suppose ये वहाँ पे fix कर दिया होता, then this bridge, because in summer when it expands, this would have a bend. Okay, it would have a bend like this because it expanded. And when it is going to contract at that time, it may even pull this land apart, and it can become shorter, and that's why it could get damaged. So that's the reason it's important that the bridge will be such that one side it is fixed and the other side it is kept flexible so that it can be moving. Okay, it can be if we are able to move in this. So that's about the construction of a bridge. In the construction of a bridge, steel girdles are used. One end A of the girdle is fixed to the concrete, but the other end B is not fixed into the concrete or pillar. It is supported on rollers as shown in the figure 6.7. So that if there is any rise or fall in temperature during summer or winter, girdles may expand or contract without affecting the pillar and the bridge. So without affecting the pillar or the bridge, it can easily go out, means it can extend or it can contract without any kind of a problem found to the bridge. So the bridge will remain intact whether it is any temperature conditions. Now this is much more important when the temperature conditions between the summer and the winter is very high. Now you can see that in places like Delhi and all, you find that the summer is very hot as almost like 45-46 degree temperature, whereas the winters are very cold, almost like 0 degrees or 1 degree Celsius. So the range from 1 degree or 2 degrees Celsius to 50 degrees Celsius is quite a big range, where the expansion and contraction when the length of the bridge is very high is going to make a problem. So that's why it is necessary that to have such a kind of arrangement so that it is not going to have any problems. Similarly, the next case is of the railway track. Now in the railway tracks, if you see the railway tracks, what happens is that, so it is this way, that if these are the two railway tracks, so this is one track, and there is a second track here. So and there are normally sleepers in between those two tracks. So these are the sleepers which are there between the tracks. Now it is seen that when these tracks are being connected, so one length of the track may be something like 10 meters or 12 meters length will be there, and so if one track is there and then they put the other track over here, at that time they are going to place a gap between the two. There is a gap, you can see there is a gap over here. This is the gap between the two things. So this particular gap is kept. Now why is it kept? Same way, expansion, contraction. See, when the gap is there, when the train moves, there is a lot of amount of heat which is generated due to the friction on the track. So there will be an increase in the size, that is the expansion of the track is going to take place. एंड सेम वे इवन विंटर कंडीशन भी हो सकता है जहाँ पे कॉन्ट्रैक्शन होगा, समर में एक्सपैंड होगा, वो तो होता ही है. Moreover, it is basically the friction, which is that when the train passes through, the friction of the train will automatically allow it to expand. So this gap over here, as soon as the train passes, the expansion is going to take place and it is going to come very close to each other. When the train is passing and it is cooled down, so again it will be back to normal. So in this way, the train will be able to go smoothly on this thing because the gap will not be so big that it can have a kind of a hindrance to the train for its travel. But if this particular gap would have not been kept, then what would happen is that there will be expansion and the track instead will get bent. So it is going to bend like this because it's fixed to the ground, so it is going to bend like this and there could be a derailment of the train. So that's why it's important that such a kind of a gap be placed between the two tracks, and there is a fish plate which is going to be there in between these two. So there is a fish plate over here which is bolting the two together, okay, so that they are not getting distorted. So railway tracks, the rails of the railway track are made up of steel. While laying the railway track on the wooden or concrete plank, a small gap is left between the successive rails at length of the rails as shown in the figure 6.8. The reason is that in summer, due to considerable rise in the atmospheric temperature, each rail tends to increase in its length. So a gap is left between the two rails, otherwise the rail will bend sideways. So anyway, they are not given the example of the friction what I have told you, but doesn't matter. You need not mention that in your paper, in your answers that due to expansion, due to friction. What you can just say over here is, as written over here, is basically the difference in the temperature in the summer and the winter. So that's why we see that if it is the summer season, it is going to expand and the gap will automatically become less. In winter season, the gap will automatically be more. But at the same time, if the gap would have not been there, then in summer season, they would have bent like this. So it will be sideways. And that sideways, when I say, the train could get derailed. So that's the reason, to avoid accidents and all, they always require to keep a gap between the two railway tracks. The next is riveting. Now, riveting is a completely different process. Now, the riveting is done for joining two steel plates in such a way that they are almost airtight. Not almost, it is completely airtight, it is steam tight in fact. Okay, they are steam tight. Now how it is done? So what is done in case of riveting is the two planks or the two steel plates which needs to be connected to each other. Suppose I take this particular kind of a plate which is like this. I'm showing a cross section. So it is like this. The plate is like this. I can see only this much part. So this is like this. So this is a plate. Okay, this is a plate which I'm putting it this way. So this is what you can see. You are going to take another plate which is going to place like this. So another plate is going to be placed over here like this. Now what you want to do is that you need to connect them together. Of course you can do welding also, but welding will take a long time and it is going to be time consuming. Whereas if you see riveting is very fast. What you do is that you are just going to drill a hole. So what exactly you do is drill a hole over here. So you drill a hole over here like this. So this will be the hole. And inside this hole, you are going to place a rivet which is of this shape. Okay, this is the shape of the rivet. So what exactly this does is that you are going to place it inside and then you are going to start hammering it. Okay, this particular. So it is going to be this way. In fact, you are going to place it ulta. You are going to place it like this with the head over here like this. So this is how you are going to place it. And then you are going to start hammering over here. Okay, but when you hammer it, before hammering it, you are going to heat this rivet over here. The rivet is going to be heated. Now when it is going to be heated, what is going to happen is that this red hot rivet is going to come over here, fit over here, and because it is hot, you can hammer it very easily. So you're going to hammer it, and when you hammer it, it is just going to become flat over here. So this is just going to turn into a flat thing like this. Moreover, because it is hot right now, therefore hammering से कम ये तो tight हो ही गया था. Okay, this was already filled up. But then when it cools down, it is going to contract in size. When this is going to cool down, it has already expanded right now. Maybe just a very minute fraction से expand हुआ है. But हम लोग ने hammer करने के बाद में जो tight कर दिया था, उसके बाद में when it contracts, it tightens this much more so that it becomes steam proof. Then even steam cannot pass through this particular thing. That is why rivets are very easy and fast method of connecting two plates together. So let's see what is given here. Riveting. For joining two steel plates, they are placed one above the other and a hole are drilled through them. The rivets, small steel rods, are heated red hot and then they are inserted in holes of the plate. On heating, the rivets become soft, so their ends are easily hammered as heads. Now, the rivets are allowed to cool. On cooling, they contract, but they cannot regain their original size, as they have been hammered. So, they bring the plate closer and firmly grip them together, making the joint waterproof or steel-proof. Such riveting is used in joining steel girders, boiler plates, etc. So riveting is done in making big industrial equipments and in case of making steel girders, as in the bridges में भी तुम लोग देखोगे तो you will be, see if you see a bridge, if there is a bridge of steel girder, steel bridge अगर रहेगा, ये steel का ऐसा bridge बना हुआ है. So if this is a bridge, तो यहाँ पे you will find such rotted things. Even if you see a photograph of Eiffel Tower, you will find such kind of round things over there. So that round things, whatever there were connecting things over there. So over here you will see some round things. Here you will see some round things. So here the connecting things there, they are nothing but the rivets which are used. The next thing is electrical cables and telephone wires. Okay, again let's understand it. It's a very simple thing but very efficient. Because normally we do not take into consideration these things. So for example, now suppose you know very well that the wires, of course in Mumbai you don't see wires hanging around from one place to another place except for the TV cable things and all. But otherwise normally you will find that in some small cities or small towns, the wires are going to be going from one place to another by steel poles. So there will be steel pole like this, there will be a steel pole over here like this, and which will be having such kind of lines, and then this is another pole over here like this, and it will be having this line, and then the wire is connected from here and goes to this place, and then it goes further, and from here it is coming here. ऐसे करके, these are the way the wires are going to be connected to each other. Now it is always done this way, that when it is supposed this laying of the cable is done in the summer season, if it is in the summer season, then they are going to make it slightly sagging. Okay? In the summer season, if they are placing the wire from one pole to another pole, they are going to make it slightly sagging. Why is it so? Because they consider that in summer the wire had expanded, so that's why if you keep it sagging, so automatically in the winter season when the wire contracts, at that time it will almost become straight. Because if you don't keep it sagging, suppose in the summer I have kept it like this straight, what will happen in the winter season? It will contract, and when it contracts, it will have such a strong strength that it can even put the poles out of the ground. Okay, हो सकता है कि poles भी uproot हो जाए. So that's the reason the wires which are being laid, they are going to be made sagging. Okay. Similarly, if the thing is done in winter, then they are going to make it tight. Why is it making tight? So that in summer they don't sag too much. Okay. So that's why in winter they will be laying them straight, whereas in summer it will be laying sagging. Okay. So the electric cable is an overhead power transmission line, and the telephone wire between two poles may break in winter due to contraction and may sag in summer due to expansion. Therefore, while putting up the wires between two poles, care is taken that in summer they are kept slightly loose, or so that they may not break in winter due to contraction. While laying them in winter, they are kept tight so that they may not sag too much in summer due to expansion. So in this way, they are taking care of the wire not being too tight nor sagging, so that they are protected well throughout the year. That was about the electric cables and wires. The next we see is fitting a steel rim on a horse cart wheel. Now you can see the horse cart, the horse cart or a bullock cart and all, they will be having the wooden kind of a wheels. So wheels are made up of wood. But if you make it completely only of wood, then what will happen is that because these bullock carts and all are need to travel in the rough patch of the villages, it will happen. What will happen is that slowly and steadily this whole wooden part would have got eroded out. Okay, it will get घिस के पूरा wear and tear हो जाएगा. So what they do is that they are going to place, so if this is the wheel, so what they do is, if this is the wheel over here, so this is like this. So what exactly they do is they place a steel kind of a rim on top of it. Okay, they place a steel rim on top of it, so that when the cart is moving, they are not getting abrated. Now this ring, when they are placing it, it is not placed by any kind of nails or any kind of a screw and nut and all. No, it is done in such a way that the size of the ring and the size of the wheel is exactly the same. Okay, the size of the rim. So if this is the rim, so size of the rim and the size of the wheel is exactly the same, such that ये अंदर जाएगा ही नहीं. Then what they do, they hit this rim. So when they hit this rim, it expands, so it can go like this, and then they suddenly cool it, so it cramps up. So in this way, the wheels are fitted with this particular steel rims without any kind of the screws or nuts and bolts or anything like that. Okay. So the wooden wheel of a horse cart is fitted with a steel rim to make it strong and smooth. To ensure a tight fit, a steel rim over the wooden wheel. The rim is made slightly smaller in diameter than the wooden wheel. Okay, they again more slightly, in fact, not even same size, but it will be slightly smaller than the diameter of the wheel. Then to fit the rim, it is first heated uniformly along its circumference till its diameter becomes slightly more than that of the wooden wheel. The rim is then slipped over the wooden wheel before allowing to cool. On cooling, the rim contracts and makes a tight fit over the wooden wheel as shown in the figure. So this is how we are going to, they are going to place the wooden wheel के ऊपर एक steel rim of almost, in fact, smaller the size than that of the wooden wheel. So this is giving you a tight fit because it's already smaller. That's why क्या होता है, जब ये shrink होगा, it will come to the original position, and at that time it will press the wooden part properly and will firmly fit into the on the wheel. Because अगर वो possible है, नहीं तो movement के बाद में भी वो निकल सकता है. Okay, if it is slightly bigger in size, then it can easily get removed. But because it is smaller in size, that's why even if the cart is moving in a very high speed and the friction is very high, it will not be coming out. So that was about the wheel. The next example is of the glassware used in kitchen. Now we know very well, normally, see nowadays you don't face a problem because most of the glass are heat resistant. So these glass are something which can use in the even in the microwave oven or things like that. So not a problem. But originally in older days, it used to happen that the glass जो है, they were not of a quality that you can pour hot water or hot cold drink or hot beverage like a tea or coffee directly into the glass. So if you put it, then the chances are that the glass will break. Why would that break? Because glass is a very brittle material with very little expansion or very little elasticity. So when you pour the hot thing inside, it expands, and when it expands, it is not elastic enough to expand, and that's why it cracks. So the glass would crack. So that's why the kind of glass which is used in kitchen is called as Pyrex glass. The Pyrex glass are the one which can have a good amount of expansion and contraction possible, so it's slightly elastic in nature, which will not, it's not brittle, and that's why it can be used in case of cooking. So the glassware used in kitchen are generally made out of Pyrex glass. Even in the laboratory, the test tube and all are made in that way. The reason is that the Pyrex glass has a very low coefficient of cubical expansion. You can see the Pyrex glass, they say, uska cubical expansion is very, very low, and that's why they expand minutely, very, very minutely they expand, and that's why it can sustain that particular expansion. So the glassware on being heated do not expand much, and therefore they do not crack. The next is pendulum of a clock is made up of invar. So we discussed it last time also. Invar is the alloy of nickel and iron, and this nickel and iron का जो alloy है, it has got a negligible expansion. Now how is it important? Now see, nowadays the clocks का pendulum जो होता है वो तो ऐसे time pass के लिए रहता है. You know, they are not the actual pendulums. They are the pendulum which are connected to a battery, and it is just moving for show purpose. So the clock is not functioning because of the movement of the pendulum. See, in olden days, the clock was functioning because of the movement of the pendulum. And so, if the pendulum is made up of material which would expand and contract due to heat and due to summer and winter, it would happen that it is seen that pendulum ka size ke upar the time period is dependent on. So one time period is dependent on the pendulum ka size. If the size is smaller, it will be faster. If it is longer, it will be slower. Okay, one oscillation will be faster in case of small pendulum, it will be slower in case of a big pendulum. So if at all, it used to happen that the pendulum is going to be expanding in summer, then the watch would lose time, it will go slow. Whereas in winters, when the pendulum size becomes smaller because of contraction, the clock would go faster. So to avoid this thing, what they did was that they made pendulum of invar, which has a very, very minute, very, very little coefficient of expansion, due to which, whether it is summer or winter, the size of the pendulum remains almost constant. Hence, the watch is giving you the exact time every time. So that's the thing. The pendulum invar is an alloy of iron and nickel, and it has a negligibly small coefficient of linear expansion. Is equal to 9 into 10 is to minus 7 per degree Celsius. The pendulum of invar helps the clock neither to lose time in summer due to expansion, nor gain time in winter during because of contraction. So this is how the pendulum is going to be made up of pendulum made up of invar is suitable for the watch clocks. The next is eighth one is loosening a glass stopper or a metal screw cap. Now this you must have seen many times in your house, your mother doing these things. Like for example, if she is not able to open up a cap of a, let's say a jam bottle, okay, glass ka jam bottle hai aur uske upar metal ka cap hai, and if she is not able to open up that particular cap, what they do is that she will take the bottle and place the cap, heat the cap a bit. When you heat the cap a bit, the cap will automatically expand and it will get easily be opened up. Or you are going to cool down the so normally what will happen is this would normally mainly happen when the jam bottle is kept in the refrigerator. So when it is kept in the refrigerator, so what happens, the cap jo hai wo cap thanda ho gaya, so it is contracted, and because it is contracted, it has hold the bottle very tightly. So you are just trying to loosen this up. So that is exactly what is due to thermal expansion. A glass stopper or a bottle is loosened by warming the neck of the bottle. The reason is that on warming the neck of the bottle, the neck expands and the glass stopper in it gets space to loosen. Now this is for a stopper. So what is stopper? Stopper is like this. Like agar ye neck hai bottle ka and something which is placed inside like this. This is a stopper. So this is a stopper wherein it is going to hold over here. A cap is the one which is like this on top of it. Cap is like this. A stopper is like this. Okay. So when you want to open the stopper, you are going to heat the neck so that it expands and this can easily be removed. Because ये tight है, वो निकल नहीं रहा है. अगर इसको heat किया तो expand होगा तो ये अपने आप निकल जाएगा. So that is for stoppers. If there is a metal screw cap on the neck, so of the bottle, so if there is a screw cap on the neck, the screw cap is heated. So on heating, the screw cap expands and it loosens up. So if it is a stopper, you are going to heat the neck, and if it is a cap, you are heating the cap. Okay, metal cap है तो metal cap को heat करेंगे. Finally, cracking of a thick glass tumbler. When a hot liquid is poured into a thick glass tumbler, it cracks. Now, this is what I told you, that if you are going to have a glass ka tumbler and you are going to put some hot beverage like tea or coffee directly into the glass, it may happen that the glass tumbler cracks. Now, why would it crack? So let's see. When a hot liquid is poured in a thick glass tumbler, it cracks. The reason is that the glass is a poor conductor of heat. When hot liquid is poured into the tumbler, the inner surface of the tumbler becomes hot while the outer surface remains at the room temperature. Therefore, the inner surface of the tumbler expands while the outer surface does not expand. This unequal expansion cracks the tumbler. So, we told you the first thing is that it is a thick glass tumbler. So, the thickness is very important. Because it is thick, so what is happening is it is acting as an insulator. Because normally if it is a thin glass, you pour the tea inside, automatically the outer side and the inner side both are going to be hot enough. So there won't be difference in temperature between the inner part and the outer part. Okay, the inner part and the outer part is going to have the same temperature if it is a thin glass. But with a thick glass, the glass being a poor conductor of heat, that's why बाहर से वो ठंडा लगेगा पर अंदर गर्म है. तो जब भी अंदर गर्म है तो अंदर का जो part है, it got hot, whereas outside is cool. So being अंदर का part being hot, it expands, but outside is cool, so there is a difference in the expansion, so it cracks. So that was about the examples of the thermal expansion of solids in our day-to-day life. So all the 9 questions which are there, 9 points which are there, are very, very important questions for give reason. Okay, they can ask you as a give reason over here, because this is the application based question. So when you talk about application based questions, these are the 9 things which can be coming up as the application based questions. So that was about the applications. Next what we see is the thermal expansion of liquids. Okay, so this was about the thermal expansion of solids. Now we see what will happen if there is a thermal expansion of liquids. Like solids, liquids also usually expand on heating. So similar to solids, liquids also are going to expand on heating. Liquid expands much more than solid when heated. So in fact, the expansion of the liquid is much more than the expansion of the solids. We know very well that because the liquid, when it is there, the intermolecular force of attraction is very less, so that's why they can move around much more freely than that of the solids. That's the reason the liquids are going to expand more than solids. Liquids do not have a definite shape, but they have a definite volume. Therefore, the liquids have only cubical expansion. So, we cannot have a linear expansion or a superficial expansion in case of the liquids, because it has got only, see, volume of this thing is going to be standard. So, liquid do not have a definite shape, but they have definite volume, and because they have got only a definite volume, therefore the kind of the expansion what can take place in case of the liquids will be only volumetric, that is cubical expansion. So cubical expansion is the only thing what can take place in case of liquids. But of course there's exceptions. The exceptions over here we studied earlier, that is anomalous expansion. I told you that day, that in my earlier video, that anomalous expansion of water, that water is going to be, when you cool water below 4 degrees Celsius to 0 degrees Celsius, instead of contracting, it expands. And similarly, when you are heating the water, the ice to convert into water, at that time it's from 0 degrees Celsius to 4 degrees Celsius, instead of expanding, the water contracts. So this is the abnormal behavior of the water, and that is called as anomalous behavior of water. Water contracts on heating it from 0 degrees to 4 degrees, and then beyond 4 degrees to further heating, it expands. So after 4 degrees it is normal, heat karoge expand hoga. Okay, below 0 degrees it is normal, cool karoge contract hoga, that is normal. But between 0 and 4 it is going to do ulta. I am cooling it, it expands. I am heating it, it contracts. Okay, between 0 and 4 only. So this is called as the anomalous behavior of water. The cubical expansion of liquid on being heated can be demonstrated by the following simple experiment. Take an empty bottle with a tight fitting cork having a hole drilled in its middle, a drinking straw, 2 bricks, a wire gauge and a burner. Okay, so let's see what we need over here. I think I'll continue with this in the next video.